Good evening, my name is Sam Miller, and today I will be presenting on operating systems and firewalls for ISA 4220. Specifically, I'm going to cover the Windows Server 2022 and Ubuntu Server 24 and the firewall solutions built into each and how to harden both of these respective servers. So before I dive in, let's define what a server is. A server is essentially a computer that provides resources or services like websites, logins, or databases to other computers within its network. So unlike a personal laptop, it is to run 24/7 with extra hardware redundancy and security features. Operating systems like Windows Server 2022 or Ubuntu Server 24 are optimized specifically for stability and security. Since servers are always online and exposed, they are high-value targets, which is why hardening and firewalls are absolutely essential to both. So for Windows Server 2022 is what is considered an enterprise-grade server, which means that the service that this product provides meets the specific requirements that meet the demands of a large organization. So this is the most common server that you would see within corporations. Many security features have been added to Windows Server 2022, but I am going to cover a few of the most important ones that are relevant to the topics that I'm covering today, such as a major update to the secured core server, which allows a combination of both hardware, firmware, and Windows Server OS capabilities to protect against malware and rootkit exploits. UEFI Secure Boot, which ensures that only trusted OS files are run on the operating system, which helps defend against rootkit attacks. And finally, virtualization-based security, which stores credentials and keys isolated from the operating system. So if even a breach were to occur, they wouldn't be able to access high-risk credentials or very important keys. So this helps optimize the user security a little more. So to explain what hardening is in simple terms, it's to ensure that there is a reduction in attack surface and enforcing strong controls. So because servers are high profile, the less things there are to target, the less things will be targeted. So there are a few ways to harden a Windows server. I recommend by starting through group policies, GPOs, which is an internal tool used by Microsoft to enforce policy rules. That way, when it is done for one user, it is done for all. So this helps supply a more secure baseline and makes it a more centralized process. Smaller things can go a long way in server hardening, such as removing any unused server roles and features. This can help reduce any vulnerabilities. Authentication is also a very important factor as well. Multi-factor authentication for things such as remote desktop protocols so that nobody can access the computer remotely without the proper authentication. And things such as local administration password solutions to randomize local admin passwords so that nothing can be brute force attacked. Most security vulnerabilities are because of the user, so they might use a very simple password, which can also be fixed through password policies by making it a certain length or what characters are allowed, or how many days they have before they have to make a new password. It is the best way to mitigate an issue is to help provide the proper tools and rules for the user to not make any mistakes that can cause a big security issue down the road. Finally, monitoring with event logs and security information and event management. So this is a type of software that collects and analyzes security-related data from various tools such as security information management and security event management. So this helps provide real-time analysis of security events and allows the users to take appropriate action based off of what has occurred. So let's delve into what Ubuntu Server 24 has to offer. This is a widely used and favored tool within cloud and data centers. This is because of the scalability, reliability, and security that it provides its user. By design, it has fewer vulnerabilities. This is due to several factors, that of which is stricter user permissions and a smaller desktop user base, which makes it a smaller target for threat actors to pursue. Now, this doesn't mean there are no attacks, just that there are fewer than its Windows counterpart. It has built-in security features that work great for server hardening, such as AppArmor, which is used for process confinement, and the Ubuntu Security Guide for the CIS benchmark alignment. Both of which will be talked about more in the next slide when we delve further into server hardening for specifically Ubuntu. Unlike the Windows server, it is a little more flexible, but a con that comes with that is that it often requires manual security configuration. So it requires a more hands-on approach and a steeper learning curve for its users. So it might be more expensive if you might need to get an admin to help run this process rather than one that would be more simpler, such as managing a Windows server. So while Windows takes more broad steps to help ensure that a server is hardened, Ubuntu focuses more on smaller but impactful steps in the scheme of things. So doing things such as enabling automatic security updates can help provide a more secure environment and prevent any zero-day attacks in which hackers will try to find vulnerabilities from the previous patch. If a user is slow to update the respective server, then someone might be able to infiltrate because they are operating on any now unsupported previous patch. Other things such as disabling root login to stop brute force attempts. So this forces the user to have to not only guess the password, but the user's name as well. So it's just a little bit of an extra security that helps provide more time and help deter any attacks that might want to take place. Placing AppArmor into enforce mode so that any unauthorized actions are both blocked but also logged. So this would make it so that the user is unable to make any changes that could possibly threaten the integrity of the server security and provide data for anybody looking back through the logs of who and when tried to make a change. Doing things such as using SSH keys instead of passwords is another good step towards server hardening, as it offers another form of authentication, making it a simpler way to access remote servers. The process would involve generating a pair of cryptographic keys, a public and private key. This would make it more complex and difficult to crack or guess compared to any common password that someone might create. It's just another way to help protect against any brute force attacks. So let's delve into the firewall side of things. A Windows firewall is built into the Windows operating system and works across domain, private, and public profiles. It filters both inbound and outbound traffic based on protocol, IP, and port. In an enterprise environment, integration with group policy ensures a consistent and centralized policies all around the board and rules across profiles for a more well-rounded management approach. So by default, inbound traffic would be blocked, outbound traffic would be allowed. I'm going to discuss more on this on the next slide. So for blocking inbound and allowing outbound, we want a little more control. So again, back to our favorite tool, the group policy. We can make it so that end users cannot modify firewall settings. This one is pretty self-explanatory. This is an important rule to place so that no unnecessary changes are made, which can also create a security risk. Rules should be application specific as well, so no broad strokes made. So for example of what a proper rule would look like would be allow chrome.exe on port 443 and not allow all outbound HTTPS. All Windows firewall inbound and outbound rules should specify details about the application, port range used, and creation dates of these changes so that they can be reviewed properly. Also, it's a good way just to track the progress made on the server so that you know what you've done and not bother about having to check through the policies again. On the Linux side of things, with our Ubuntu server, we use what is called IP tables, which is the most common firewall tool for Linux-based machines. It's part of the Linux kernel firewall and requires root privileges to use. So rules are organized into change, input, forward, and output. Input controls incoming traffic, forward controls what is passing through the server, and output controls what is going out of the traffic. Again, this will be talked more about in depth on the following side. IP tables is powerful, but command line only, which can be, again, a learning curve for beginners, but it also provides another level of security. So to harden IP tables, which is a good practice to have for all server hardening, is the default deny stance, kind of a guilty until proven innocent mindset. So an example of that, input and forward chains are set to drop, while output is usually accept for updates. So only allow loopbacks and established connections. The loopback interface is a special virtual network which is built into every operating system. It represents the traffic that stays entirely with the host. So for example, if you were to run a local database like MySQL or Postgres and access it with the local host, it would be tested on the local server. So basically, in layman terms, the server is basically talking to itself. If loopbacks aren't enabled, the service could break, which is why it's important to make sure that both inbound and outbound traffics are allowed on the loopback interface. So restrict SSH access to specific management subnets and use key-based authentications. Again, another level of security. So SSH on 22, HTTPS on 443, Postgres on 5432. Add logging at a controlled rate to catch any dropped packets so that the server's logs aren't overwhelmed. Save the IP table rules, because if the server is rebooted, it doesn't automatically save those rules unless you do so manually. So if you don't want to lose your progress, make sure that you do that. So in summary, Windows Server 2022 emphasizes secured core features and a centralized baseline. It is more user-friendly, but that means by nature it has a larger user base, making it a main target for attacks. And Ubuntu focuses on strict permissions, app armor, and in subjective terms, a more quote-unquote simpler hardening practice, but it's very technical, so very command line dependent, making the user base smaller and less susceptible to more attacks. Not no attacks, but more attacks. Firewalls, whenever that be Windows or Ubuntu, should always follow the principle of default deny and explicit allow. This makes the environment more controlled, and if something needs to be changed, it needs to be done manually to ensure that it is necessary to just think out the steps that were required to make those changes and what those changes affect. Security is not just a configuration, it's not just about changing policies, but it's just an ongoing review and monitoring of the product. For the most part, it's about being aware of your surroundings, knowing what affects those surroundings, and ensure what's in place is controlled and understood. Thank you for listening to my presentation.